We're supposed to All right. So it's my pleasure to introduce Scott Ritchie. Scott received his PhD from University of Florida. Worked at Mosquito Vector Control District in Florida for a little while, and then moved over to Australia, where he spent in Queensland chasing container breeding Hades and dengue. He's now at James Cook University, professor there, and he's going to talk about Let the Mosquitoes Loose, a tale of two Wolbachias.
Thanks, Guy. Thanks, Bill. Thanks for having me here. And let's just hope I can master the technology. Lovely weather you've dialed up for us. Come on. There we go. Okay. Boom. So yeah, I used to, this is me many, many years ago. It's so old, this photo. That's the paycheck stuff. Don't see those anymore. But I was at Collier Mosquito Control District, and we used to kill mosquitoes in a very big way. And mosquitoes coming in from the Everglades, they spray thermal fog, dibro. And anyway, this is the areas we're going to be talking about, Cairns and Townsville in Australia. And I eventually moved to Cairns, where I was responsible for the state Queensland Health's dengue control program. And you can see we got a lot of dengue in North Queensland. So it's an issue that we have there, ongoing issue in Australia. And like I said, I used to manage that program. And it was interesting, to say the least. But now, instead of people paying millions of dollars to kill mosquitoes, people are paying millions of dollars to release them. So this is a bunch of politicians in Brazil releasing cups full of mosquitoes. And I call this sort of technology rear and release. So it's a new thing that started, it's really taken off vector control. That is rearing and releasing millions of mosquitoes so that you can somehow modify the existing population and either eliminate it or reduce its capacity to spread and carry pathogenic viruses like dengue. So anyway, this is a bit of the outline. So the Wolbachia rear and release paradigm. So how Wolbachia works to knock out mozzies and viruses. Mozzies is the Australian term for skeeter. Different Wolbachia strategies, virus blocking, which is population replacement, and population suppression, which is sterile insect techniques, by another name. Relative merits of both and challenges ahead. So Aedes aegypti, here you have Aedes aegypti. In fact, somewhere on campus there's Aedes aegypti. I think they escaped from Ritchie's lab. That's probably where they came. But a container mosquito is one that lays its eggs and utilizes containers, artificial containers, that fill with water and produces some mosquitoes. So Aedes aegypti is common in tires, bird baths, pet bowls, buckets, and things like this. The other thing about it, at least in Australia, but typically in Southeast Asia and Latin America, is it really likes hanging around people and going indoors. So we call it, I call it a cockroach mosquito. So it's very domesticated, almost like your urban cockroach. So this is the type of house we have in Australia called an old Queenslander. I live in an old Queenslander. They're great, beautiful old wooden houses, but they're not screened. So mosquitoes just fly straight in the house. And they feed on you indoors. Of course, these mosquitoes also carry dangerous diseases like dengue hemorrhagic fever, and dengue is really taking off. I shouldn't be moving around because poor old Davis can't see me, so I use a mouse. But dengue has really become pandemic. It has really escalated in the last 3 decades. Another disease is chikungunya, which is a Makunde word for that which bends up. And it really gives you this horrible arthritis. Very uncomfortable indeed. This is a great picture. This poor woman, you just see she's all bent over and stuff. But the other one that's come in the last few years has been Zika virus. And we've all seen these heart-rending photos, pictures of babies with microcephaly. And that's been one of the biggest tragedies. And indeed, it was WHO declared this is the first for vector-borne disease, a public health emergency for Zika virus. And of course, it created this great sense of urgency. And one of the things I remember out of that whole ordeal, the whole Zika thing, they'd always have a picture of somebody with foggers, spraying, fogging outdoors, sometimes areas you don't even have Aedes aegypti. So here's a fogger. You know, it's a lethal but transient cloud. It doesn't offer any sort of longevity as far as a method. This is one of my favorite photos. Here they are spraying the cricket. And, you know, I don't think there's any mosquitoes in there. They feel good about it, I suppose. And the big issue that we've had with all this insecticide use going on in areas where they do have a lot of Aedes aegypti is pesticide resistance. It's really become a global issue. And most areas you go to, most large urban areas, we see big endemics or big outbreaks of dengue and Zika, et cetera, have had resistance to pesticides developed. And that's part of the reason the mosquitoes are not really, the mosquito control isn't working that well. In fact, Margaret Chan of WHO said, the vector control guys dropped the ball. And she was very critical of the whole thing. So anyway, there's been a big effort to find alternative methods of controlling mosquitoes. Of course, the other thing is non-targets. You know, people want something green. They want something that's not going to kill other insects and poison the environment. So one of them is Wolbachia. So Wolbachia is a bacteria, and it does a lot of strange things to manipulate the host. And one is it can turn males into females, it can be male killing, and so there's been used, just started being used for mosquitoes to control and to actually release males that have Wolbachia to mate with wild females and sterilize. But there's some other properties of Wolbachia too. And Scott O'Neill, he's with, used to be with Monash University, and now he's with a program called World Mosquito Program. It was formerly called Eliminate Dengue, and this is our lab, and mainly funded by this guy in the middle there, Bill Gates, Linda Gates, and a couple of fellows. This is Eric Hoffman on the left. He's been very instrumental in all this whole Wolbachia movement. And Michael Torelli, from UC Davis. He's been one of the early guys involved with the ecological model. And I'm going to see him in a few days. Anyway, that program now is called World Mosquito Program. We're going to try and see if I can make this work. You got to make that kind of noise. Boom.
The mosquito known as Aedes aegypti originated in Africa. Over the last 400 years, it has spread throughout all tropical regions of the world, transmitting viruses to people. We are working on a way to stop this mosquito from transmitting dengue. Our method uses naturally occurring bacteria called Wolbachia that live inside insect cells and are passed from one generation to the next through the insect's eggs. Wolbachia are found naturally in up to 60% of all the different species of insects. Insects that include fruit flies, moths, dragonflies, and butterflies. The secret to the success of Wolbachia is how it manipulates the reproduction of the insects it lives in, so to give itself an advantage. It works like this. If a male insect has Wolbachia and mates with a female that doesn't, then the eggs she lays won't hatch. If the female has Wolbachia and the male doesn't, she would lay her normal number of eggs. They would all hatch, and all offspring will carry Wolbachia. When two insects that both carry Wolbachia mate, The eggs will hatch, and all offspring will carry Wolbachia. Over a few generations, the number of individuals carrying Wolbachia increases rapidly until nearly all the insects within a population have the bacteria. We wanted to see if we could use Wolbachia as a way to stop dengue transmission. To do this, we first had to move Wolbachia into the mosquito so that it would grow and be passed between generations. Using microscopic needles, we took Wolbachia from the fruit fly and injected it directly into young Aedes aegypti eggs. It took us thousands and thousands of attempts, but finally, we were successful. We then took the mosquitoes that contained Wolbachia and infected them with dengue and found something really exciting. The virus didn't grow well in the mosquito, and if it can't grow, it can't be passed between people. Our next step was to build large enclosed outdoor cages in northern Australia that we filled with local mosquitoes. We then introduced mosquitoes containing Wolbachia to see if it could spread into the cage population, and it did. We now wanted to test the method where dengue is found, but before we did this, we needed the government to examine the safety of our method and approve our trials. Then we needed to gain the support and approval of communities to release mosquitoes containing Wolbachia. With these approvals, we began our first open field trials in Australia in 2011. Wolbachia mosquitoes were released once a week for 10 weeks, and within a few months, close to 100% of the mosquitoes had Wolbachia. And years later, they still do. Ongoing trials in Australia and dengue endemic countries are now determining the best way to deploy Wolbachia across whole cities. It is our hope that with continued success, the Wolbachia control method will protect the health of the 2.5 billion people that live in dengue transmission areas.
Okay, that's good. Now, you start playing some other rubbish here. Here we go. Anyway, I don't have to go into this. That's how they got it in the eggs in the first place. And the important thing to keep in mind is this first cross right here. So if you have a male mosquito that's got Wolbachia and it mates with a wild female, uninfected, through the cytoplasmic incompatibility, the eggs are basically infertile. Okay, you get some development within the embryo, but it doesn't complete and they don't hatch, and it's like 100%. So that's a powerful drive mechanism that you can use to introduce Wolbachia into mosquito population. And here's sort of the way, here's the whole strategy is somebody's out there releasing cups of adult mosquitoes. You can see that the Wolbachia eventually gets established in the entire population. So much for that. That's weird. What have I done? It's very straight. Hold on, everyone. There we go. Okay, so one of the big aspects of the rear and release, you know, we're used to going around telling people, tip out your buckets, clean up your yard, use mosquito coils. We got a spray inside your house to kill mosquitoes. And all of a sudden we're telling them, hey, is it okay if I release a cup of 100 mosquitoes outside your house? They looked at us like we were mad. So it really took, as I said, it took a lot of community engagement. It took a lot of sausage sizzles in order to get people convinced to let us release mosquitoes. But they did. In the end. And so the colleague who's worked on a lot of this stuff, the CE, as we call it, community engagement stuff, is this sort of statement. So I'll let you read it. I don't need to read it. But it's the residents are involved with this stuff from the very beginning. And if you don't bring them along for the ride, forget it. You've got to treat them with respect. It's their house, it's their community. So you got to spend time and people to do this. So the community engagement part of these programs, it took us 2 years to get that community engagement stuff happening before a single mosquito was even thought about being released. So I think you can just go in there and just swan on in. Hey, here you go, man, we're gonna do this stuff. You can't do it that way. You can't do it that way. And there we go. Community engagement, community support, regulatory approval. Anyway, we reared the mosquitoes at our facility at James Cook University. Then the second step is, of course, releasing mosquitoes. Then the mosquitoes are monitored. And this is an overtrap here where you actually collect the eggs from wild mosquitoes and then you hatch them. And you see how many are infected with Wolbachia by PCR. And now they're using BG traps, which is a trap that catches the adult mosquito and it's flying around. And the new approach, though, that's being used in a lot of areas, instead of rearing and releasing cups of mosquitoes, is they actually put egg strips that have Wolbachia-infected mosquitoes, and they put them in a container, they put it in people's yard, and literally it's just add water. 2 weeks later, you've got your Wolbachia-infected mosquitoes coming out of here it was a noodle box, but they've got other containers now. But that's a good way because you can have one bigger lab producing egg strips and then just post the egg strips to people who will set these things up. You can engage with the community. Community can get involved. Like here's one here, they're using that method in Townsville, in Australia, and they've got almost 100% of mosquitoes infected, they're done. And here in Cairns, you can see this only goes through 2015, but the line continues now up to 2018. They're still maintaining Wolbachia in those mosquitoes. So the green here is actually the period where Wolbachia mosquitoes were released, and it has maintained itself naturally in that mosquito population without any more intervention from us. It's naturally maintained itself there since 2011. And there's a recent publication you might want to check out. But the take-home message from this publication is in Townsville. So this is imported dengues, the little black lines, and you can see there's been a steady, in fact, imported dengues have increased in the last few years into Australia because there's more and more dengue going on overseas. Okay, and there's more people traveling, picking up the virus and introducing it. The green is Wolbachia releases and the percent of areas that have Wolbachia in it. And since then, you can see that this is locally acquired dengue in the Townsville area, and you can see that since the Wolbachia's gotten in, there really has been no dengue transmission in that area. And the same goes for Cairns, the same goes for all the communities in North Queensland that have Wolbachia in them. And that is basically almost all of North Queensland. Port Douglas, Cairns, Innisfail, Townsville, Charters Towers, et cetera, et cetera. So it's been pretty good. Wolbachia also blocks the Zika virus. This paper does sort of bother me, I have to say. Anytime you get something where none of them transmitted at all, I'm always, yeah, it's a bit weird. But anyway, the Wolbachia-infected mosquitoes here on the left, or here on the right, what they do is they feed these mosquitoes a blood meal that's got Zika virus in it. So here is the wild type mosquito without Wolbachia, and here is the positive one with Wolbachia. And then they ultimately look at how many mosquitoes have a disseminated infection, so that's where the virus is spread throughout the mosquito's body. So it's gotten out of the gut. Okay, so like the wings, the legs, etc. And hopefully the salivary glands. And this is infectious virus in the saliva itself. I think that's better. Is that better Ritchie working out there?
No, that's Ritchie stuff.
Oh, jeez. Like ice guys. Yeah. Anyway, that program's been very successful, and they have, these are all the countries that are doing releases right now, or planning to do releases. So I think there's like 12 different countries where they're doing this population replacement methodology. Okay. So one of the issues with Wolbachia is there are barriers to getting it established. So I can't explain everything, but basically there's what they call an unstable equilibrium point, where if the percentage of mosquitoes that you're releasing are less than about, in this case, about 30%, okay, if it's less than that, then the Wolbachia will drop out if you don't keep adding it. If it's above that, then eventually it'll increase. And with Wolbachia, the strain of Wolbachia that we've been using, which is called WML, it looks like this unstable equilibrium is about 30%, about 0.3. And why is that important? Well, part of the reason, hey, there you go, better late than never, my thought. So one of the issues is with an unstable equilibrium about 0.3, that means if the odd mosquito jumps out from your areas that have Wolbachia into an existing population somewhere else, it's going to be, in a sense, overwhelmed by the uninfected, and Wolbachia won't establish. And this is what happens. Basically, you've got to release, if you want Wolbachia to get established, you've got to release it in that area. So here is in cans, Wolbachia had been released in this area here, which is this road right here on this side. And it never did, occasionally you would get one that would jump the road, but it would never establish, it would just disappear, okay? So the only way to establish Wolbachia in this area is they had to go in and release it. So that's one of the barriers to establish. This road acted as a migration and dispersal barrier. So the mosquitoes would not move across there in sufficient numbers to establish Wolbachia on the other side of the road. Another one is pesticide use. In a lot of areas, as I said, pesticide use is widespread, and even domestic pesticide use. And this has led to the development of resistance. And basically what can happen is your Wolbachia infected mosquitoes can be released, but if they haven't got resistant genes in it, they're going against a wild population that's got a bunch of resistant genes in it, then they'll be selectively killed. And so this is what happened in a suburb in Rio. So here they're doing releases, right? And the frequency is going up. And then as soon as they quit doing releases, the population, the frequency, the infection level of Wolbachia crashed. And so then what happened was they decided, oh, we got a problem because all wild mosquitoes are resistant. So they back-crossed those mosquitoes with a wild strain of Aedes aegypti that had resistant genes and created a Wolbachia line that was resistant to pesticides. And then they redid the releases and everything was sweet. It all worked out. Here's a big barrier, of course, regulatory approval and public acceptance. I love that bloody speed draw thing of faceless bureaucrats, right? Anyway, and really one of the big issues of all these Wolbachia things is how do you scale up for mega cities? These are the areas that have a lot of dengue, and you've got to be able to release in these big areas. Okay, so I'm going to talk about the other application for Wolbachia use, and this is a male Aedes aegypti down here. That's a female. See what they're doing? And you've all heard of, maybe you haven't, sterile insect technique, where you release sterile males in mass numbers. They mate with wild females, and the population crashes. And they've used this for years now to create this sort of barrier to prevent the screwworm fly from establishing, again, reestablishing in North America. And just a couple definitions. So this one term here that we just talked about is what they call population replacement. I like to call it population transinfection. But that's where we are releasing male and female mosquitoes with Wolbachia, and the resulting population becomes infected with Wolbachia. And I hate that term population replace. You're not replacing the population, you're just infecting it with the bacteria. Okay? The genetics of the established population don't change, I guess. Anyway, the other is this population suppression. And that's where you only release male mosquitoes that are infected with Wolbachia. You let them mate with the wild mosquitoes, but you're not introducing the Wolbachia itself. You're just using it as a tool to effectively sterilize the females. And I've been involved with a program in this past year run by Verily. They call this program Debug. They've got a little video clip I'm not going to show you here because it's sort of similar to the other one, but a bit different. But you get the idea. If you want to see it, go Verily Debug. And they've got a couple of big programs going on right now, one near Fresno, in Clovis, and then Innisfil. We're going to talk about the Innisfil program I've been involved with in the Cassowary Coast area. And for those of you who don't think birds aren't dinosaurs, I invite you to see a cassowary. And Nigel Beebe's been involved with this. Nigel has worked for CSIRO and also the University of Queensland. And the whole idea was to use Wolbachia-infected sterile males, okay? And to demonstrate that we could mass rear these buggers, release them, crash the population. That was the whole goal of the whole thing, and get through the whole bureaucratic hurdle at the same time. Anyway, this is Innisfil. It's a lovely little town right near the coast. And yeah, there are wild cassowaries wandering around in the woods. Cassowaries have killed people, by the way, but they're really neat birds. But the thing that's neat about Innisfil is there's all these barriers to mosquito movement. So you've got isolated little communities there. You can do your Wolbachia release. Each one's a little experimental unit. So here's an idea of these sort of different areas. We can have different experiments. So we were going to use WML, which is the same strain that Eliminate Dengue has released on the population replacement. Okay, but then, because Innisfil didn't have it, they didn't do releases in Innisfil. Scott O'Neill didn't. But then when the Zika stuff came along, all of a sudden Queensland Health, the health department, they go, oh, you've got to release Wolbachia everywhere. We're scared to death of Zika. It worked so well, please do it. So they released Wolbachia everywhere, including Innisfil, which sort of screwed up our whole goddamn program approach. I told you, Brian, there was some blind politics involved. This one was a doozy. Anyway, O'Neill went ahead and did the whole Wolbachia releases, and then we had to figure out what the hell we could do. So we ended up using a new strain of Wolbachia, WLB, because there are multiple strains of Wolbachia. And if you have a different strain, when it mates with a wild female that has a different strain of Wolbachia, it can still sterilize. So you can use different combinations to do that. And that's what we had to do. And we had to get the politics were huge. Anyway, here's the sort of study areas we were doing. We had 3 different treatment control groups. And each one of those had about 250 houses. We released 3 times a week. The adults were monitored with BG traps and then also ovid traps to see if the eggs were indeed being sterilized. And they had a whole digital data stream platform. So we had Verily involved. Verily is Google, okay? And so I had, this was a heavily geeked project that had all kinds of stuff. And they did PCR the mosquitoes that we got for Wolbachia, and et cetera. Anyway, here is a couple of the fun things that we were involved with as part of that program. One of the things we wanted to do was figure out if these Wolbachia-infected mosquitoes that are being reared through Verily sort of high-tech equipment, do they mate with females readily? Maybe they're a bit screwed up. We don't know that. So we developed a marker, this rhodamine B. It's about the color of a beetroot juice. And when the males have this rhodamine in it, and they mate with a female, the juice, the dye, goes into her spermatheca. So if you dissect the female, then you can see whether or not your males are actually mating with a female, so wild females. Here's a couple of pictures. Here's a female that's got rhodamine in her. She's fed on this. Here's a male that's got it. And here is a female, because this stuff fluoresces. So if you get a fluorescent microscope, you put it under there, and you can see here's a spermatheca, the person, and a spermatheca that obviously had been mated by one of our male mosquitoes that had rhodamine in it. So that was sort of fun. That was a fun method. And from that, we could figure out how far males fly. Do they mate with the females? Can we release them during the day? Can we release them at night? Which was sort of neat. Sort of release them at night. And then modeling how far the mosquitoes are moving, the male released ones, and also to use to estimate the population of wild females. Okay, I'd like to show you all sorts of neat pictures of all the kit, all the Verily, all the Google stuff. But we made us sign these confidentiality agreements, non-disclosure agreements. So if I start showing you pictures and telling you this stuff, I will meet with a very instantaneous and certain death. So I can't do this. So anyway, here's some of the bits. We did not use the sort of robotic larval rearing thing. So we did that the old-fashioned way. And here's old mosquito egg being produced. Here's pupae, zillions of pupae. And one thing about this method is you have to only release male mosquitoes that are infected. So you've got to sort the sexes. You got to figure out how to separate the boys from the girls. And they had a real high-tech fancy stuff. But, you know, if I show you what it is, I'll be on the ground. And here's their delivery vehicle. So they had a van, they drove around, had a GPS system in there, made a map, and it automatically fired mosquitoes, male Wolbachia infected mosquitoes, out of the van. Pretty cool stuff. And then they made this like dashboard, showed you what the hell's going on, which we'll look at in a minute. And this is larvae coming out of overtraps. So the control area is a sort of bluish up here, and the treatment area is the sort of red. And you can see that the treatment area, the number of mosquitoes that were hatching out of overtraps crashed. It went down really, really, really low. I say, what about the adults? And here's the adults who'll be picking up adult female Aedes aegypti from BG traps. Here's the control areas, and here's the treatment. So this is when we started doing releases, this arrow, and you can see that it's the population drop and drop. And the modeling team will tell us there's about a 85% reduction in the control area versus, in the treatment area versus control. And sensors. They want to build traps that will automatically detect Aedes aegypti. And one thing I've been involved with is traps that catch male mosquitoes. And male Aedes aegypti actually are attracted to the female wing beat frequency. So that buzzing sound the mosquitoes make, I did have a video clip, but I don't have it because it won't play because it's a stupid Mac stuff. And let's see, but I can at least play this tune for you because this is what she sounds like. And I had a little video. Here we go. Let's make sure everything's on. It sounds like that, wherever the microphone is. But anyway, I can take this phone and stick it in a cage full of male Aedes aegypti, and they will try to mate with my phone. And so you gotta clean your phone, you gotta be very careful. And so I remember the first time I did a trial. I got this trap, we called it a GAT, gravid Aedes. There we go. That trap right there. And I put the iPhone in there playing that thing, and the males just flew right in the goddamn thing. from an iPhone. I said, people love this. Say, will you host a trap? Yeah, you get a free iPhone. Yeah, of course I will. So anyway, we built these bloody little sound lures, and it was pretty cool. This one's pretty cheap. This costs about $25 for the trap and the sound lure and all that kind of stuff. And we just publish this stuff. Plus one, so I have a little. And basically, we had a normal BG trap, and then we had this gat, and I call it the sound gat. And this is the abundance of male Aedes aegypti. And you can see here that without the sound lure in it, you get hardly any, and then you add the sound lure, and your male collections shoot up. In fact, they're as good as what you would get in a BG trap. And then looking at overall collections, normally the gat catches about a quarter of what a BG does. At a sound lure, you're starting to approach about half of what a BG gets. So anyway, we are making a new trap. We call it the male Aedes sound trap, the mask. It's going to have a printed circuit board, standalone use, so you can take this trap, either put it with a gat or buy a BG or whatever, or set it all by itself. And you can set the flight tone for Egypti or Albopictus. It's very specific, this trap. You get hardly any bycatch at all. We're still measuring that. We want to have, it'll have an automatic counter. When the mosquito enters, it'll count it. And then it'll beam it up the cloud. So it'll be a mosquito sensor platform, all set around. I can't show you what it looks like though. Remember, NDA. But here it is versus our normal sound gap. There's a couple of early versions of the mask, and you can see that they had significantly more. It's pretty cool, actually. Anyway, that's sort of the various people involved in the whole Verily thing, blah, blah, blah. Okay, what's next? Mission accomplished. You all remember what happened with George Bush. And we published a paper on this, and I am a bit worried that Wolbachia could drop out. And here is a study that was recently published that shows when you rear mosquitoes at very high temperatures, so this is like 36 degrees centigrade, the amount of Wolbachia in the mosquitoes drops way down. So it's almost like it cooks them. Okay, another thing is that some mosquitoes, and this is a complicated slide, but I'm going to just say, mark these reds over here mean the mosquitoes are able to transmit dengue. And these are infected with Wolbachia, but you still had some that were transmitting dengue virus. So the worry here is that maybe you'll select for a resistant virus against dengue. That could be a worry. The other one is Aedes albopictus, Asian tiger mosquito. In Florida, the Asian tiger mosquito, there used to be Egypti all over Florida. The Asian tiger mosquito came in and it moved down to the whole state, and Egypti basically disappeared from most of Florida, except far southern Florida. Okay? It's a great displacer, I call it. Same thing happened in the Torres Strait. So this is the very tip of Queensland. These are these islands here. Used to have a lot of Aedes aegypti. Used to have a lot of dengue outbreaks. And now it's all albopictus in there, no more aegypti. So, I'm worried that albopictus can come in and displace all those Wolbachia-infected mosquitoes and get rid of them. The other thing is with these release of sterile males. So this is actually a program using Riddle, which is a genetically modified mosquito, but it's still sterilized. It works the same sort of way as far as impound populations. And here's releases. So here is the dark is populations of mosquitoes, the natural ones. And here is releases of the sterile males. And what happens when you quit releasing? This is what happens. You quit releasing and populations rebound, come right out. So once you start releasing, you can be stuck and be on that treadmill. Okay, so I just wanted to end with this. And this is a picture I've been talking about. This is a guy named Fred Sober. This is not Fred, but he had this program of perifocal spraying using DDT. And they all been eliminated Aedes aegypti through much of Central and South America. American. And then the whole thing sort of fell into heat. You got resistance, a lot of things. Yeah. The whole thing sort of fell apart. But it did work really well for quite a while. And I'm just wondering, you know, what's going to happen? This Wolbachia, is it going to be a great panacea? Is it going to be rolled out around the world and work real well, or is it going to break down, or what's going to happen? The future will tell us. Who knows? As I say, what's the next big thing? Okay, a lot of people. I want to thank Bill Wall. But a whole bunch of people acknowledge, and that's it for me. I'm talking about.